Once we know how to find the total number of outcomes for compound events, we can calculate the compound probabilities with independent or dependent events. So let's say we have the following tickets, a green, an orange, and a purple. One ticket is pulled out of the box at random. The ticket is not put back in the box. What is the probability of pulling one green and then one orange? So this would be considered a dependent event because one is affected over the other. So we have these three tickets and we're not putting it back in the box. So if I pull a green, my only options then are orange or purple. If I pull the orange, my only options are green and purple. And if I pull a purple, my only option is green or orange. So the probability of getting a green ticket is 1 out of 3. So then I'm going to be focusing just on these first set because these are no longer valid. The probability then of getting an orange ticket after I pull the green ticket is 1 out of 2. So multiplying them together, 1/3 times 1/2 is 1 out of 6. One ticket is pulled out of the box at random, the color is recorded, and the ticket is put back in the box. So these would be considered independent events. What is the probability of pulling one green and then one orange? So if I put the green ticket back in the box, that means that I have all three to choose from for my second option. So still the probability of getting a green ticket is 1/3. We're still looking at that first set of options, and the probability of getting an orange ticket is also 1/3. So 1/3 times 1/3 is 1/9. At the end of the month, one ticket is pulled and it is not put back in the drawing. Then another ticket is pulled. What is the probability that May will win 2 certificates? So May has 4 tickets, Ashley has 2, Jack has 3, and Diego has 4. So May winning the first pull would be 4 out of 13. Let's say these pink ones are May's. There are 2, 4, 6, 8, 2, 8, 10, 12, 13 tickets. So she has 4 chances to get the first 4 out of 13. Then that ticket is no longer valid because we already pulled it out and we're not putting it back in. So these are dependent events. So May then has the possibility of winning 3. She has 3 tickets left since her first one was already taken away. Now we have 12 options left. So 4/13 times 3/12 is equal to 12 156. If I divide the top and the bottom by 12, we get 1 out of 13. Fill in the blank. In a jar, there are 5 quarters, 3 dimes, 2 nickels, and 1 penny. One coin is randomly subtracted from the jar and put in a wallet, so therefore it is not replaced. Then another coin is selected. Since it is not replaced, these are dependent events. The total number of outcomes is 110, because our first choice is 11 options. Then I'll only have 10 options left when I take one out and keep it. So 11 times 10 is 110. The probability of selecting a quarter and then a dime. So if I select a quarter, I have 5 out of 11 chances to get a quarter. I then have, let's say I did pull a quarter, I still have 3 dimes left in the jar, but now I only have 10 to choose from. So 5/11 times 3/10 is 1,510, which is equal to, when I divide them both by 5, 3/22. There are 3 pinball machines, 5 video games, and 2 racing games. What is the probability that each student will choose a video game or a pinball machine? So if there are 3 pinballs, let's represent that by P times or PPP, and racing is RR, and 5 video games, so VVVV. So the probability of choosing the pinball is 3 out of 10 since there are 10 total options. The probability of getting racing is 2 out of 10, and the probability of a video game is 5 out of 10. We're particularly interested if each student chooses both of them choosing a video game. So the probability of choosing a video game first is 5 out of 10. times the probability of choosing a video game the second is still 5 out of 10 because one does not affect the other. These are independent events. So 25 hundredths. Further, if they both choose the pinball machine, we would have the probability of choosing the pinball machine times the probability of the second student choosing the pinball machine. So 3/10 times 3/10 is 9 100ths. But because we have the word or, a video game or a pinball machine, we need to find that either of these events will occur. So both video or both pinball means we need to add their probabilities together. So 25 hundredths plus 9 hundredths is 34 hundredths, or 34%. Let's keep the same thing, except what is the probability that at least one of them will choose the pinball machine? So at least one pinball would mean that somewhere in our probability, we would need to assign at least one pinball. So pinball and pinball, video and pinball, pinball and video, racing and pinball, or pinball and racing. These are still independent events. So we know from the previous slide that pinball and pinball is 9 out of 100. Video in pinball would be 5/10 times 3/10, so 15 hundredths. That is the same probability as pinball and video. So 3/10 times 5/10 is 15 hundredths. Racing and pinball, 2/10 times 3/10 is 6 hundredths. And pinball and racing again is the same, just reversed. So now that we have all of our different options, we need to add them all together. So the probability of at least one pinball is 9 hundredths plus 15 hundredths plus 15 hundredths plus, oh, I think I have one too many. I got a little excited there apparently. Ooh, oh boy. Okay, so 9 hundredths plus 15 hundredths plus 15 hundredths plus 6 hundredths plus 6 hundredths is 51 hundredths. Again, keeping the same scenario, this time we want what is the probability that less than one of them will choose the video game. So less than one of them will choose the video game. All right, so less than one video game would be pinball and pinball, racing and racing, racing and pinball, or pinball and racing. Notice there is no video game listed in that probability. So this is the same as finding the probability with no video games. So the probability of getting pinball and pinball we know is 9 hundredths. Racing and racing, 2/10 times 2/10, which is 4 hundredths. Racing in pinball, 6 hundredths. And pinball and racing is also 6 hundredths. So we add them together. 9 hundredths plus 4 hundredths plus 6 hundredths plus 6 hundredths is 25 hundredths, or 25% probability that they will choose no video games. In the box, there are 5 caramel, 3 nut-filled, and 2 fruit-filled chocolates. What is the probability that these students will both choose 2 nut-filled or 2 fruit-filled? So we need a nut and nut choice. So the first chooses a nut and the second chooses a nut. Since we're taking up from the box of chocolates, once a chocolate is gone, we can't put it back because you're going to eat it, right? So you're not putting a bite back in the box. So these are dependent events. So there are 3 out of 10 which are nut-filled. And if I choose a nut-filled for my first option, I only have 9 left to choose for my second. And further, there are only 2 options left because I took one of them from my first option. So 3/10 times 2/9 is 6/90. Now we need the fruit and fruit. So if the first student chooses fruit, there are 2 out of 10 which are fruit. And if the second also chooses fruit, one of the fruit's already gone, so I only have 1 out of 9 chocolates left to choose from, which are fruit. So 2/90. Again, we add them together. So 2/90 plus 6/90 is 8/90, or 8.9%. Let's keep the same scenario going, except this time we want the probability of choosing at least one fruit, but we're only choosing two, but we need at least one fruit. So that would be, we would have the option of choosing fruit and fruit, nut and fruit, fruit and nut, caramel and fruit and caramel. So those are the options with at least one fruit. So 2/90ths from the previous one for fruit and fruit. Nut and fruit would be 3/10, and then fruit would be 2/9. Fruit and nut would be 2/10, and nut would be 3/9. Notice that the second option we already have one less because we already took a fruit, but it depends what the first fruit was. Caramel and fruit, caramel there are 5 out of 10 options times the fruit option 2 out of 9, plus the option of fruit and caramel 2/10 times 5/9. So multiplying them together, 2/90ths plus 6/90ths plus 6/90ths plus 10/90ths plus 10/90ths is 34/90ths. So the probability of getting greater than or one fruit when we choose two is 37.8%. Okay, keeping the same scenario, what is the probability of choosing less than 2 caramels? So this would then be the complement of choosing 2 caramels. So less than 2, the opposite of choosing less than 2 would be choosing all caramels. So what we can do is the probability of choosing less than 2 caramels is equal to 1 minus the probability of choosing a caramel and a caramel. So we don't have to write out all those pluses. It could save us some time here. Well, if I chose a caramel and then a caramel, 5 out of 10 would be caramel, times we would then have 4 left out of 9 which are caramel. So 1 minus 20/90ths, converting 1 to 90/90ths minus 20/90ths is 70/90ths or 7/9. So the probability of choosing less than 2 caramels is 77.8%. In a bag, there are 5 blue marbles, 6 red marbles, and 1 yellow marble. One marble is pulled out of the bag and the color is recorded. The marble is not put back in, so these are dependent events. Another marble is pulled out and its color is recorded. What is the probability of pulling out less than 2 blue marbles? Well, pulling out less than 2 blue marbles would be the opposite or the complement of 1 minus the probability of both of them being blue. So if they both were blue, we'd have 1 minus, there's 12 marbles altogether. 5 out of 12 for the first choice, we would have 11 left and only 4 blue ones considering we already took a blue one out. So 1 minus 20 132nds. So 132 over 132 minus 20 132nds is 112 132nds, which is 28 over 33. In the waiting room of an office, there are 7 magazines. 3 are sports, 2 are fashion, 2 are news. If 2 magazines are randomly selected, what is the probability of choosing less than 2 sports magazines? Well, then the opposite would be the complement. So 1 minus sports and sports. So 1 minus 3 out of 7 is sports. If I already take a sports magazine, there are 2 sports left and only 6 magazines to choose from. So 1 minus 6 out of 42, which is the same as 1 minus 1/7, which is the same as 7/7 minus 1/7, so 6/7. We'll pause here.